Hello. Okay. Great. Okay, so this is one page of what we do in Monash e-research. There's a lot of words in there, but as you can see that we, from the bottom to the top, we have a lot of contributors and partners that we work with, especially in the Australian space. You can see that we have ARDC, POSI, NCI, all the big names that we all knows about. And at the same time, we have a lot of partnership with the vendors who are, most of you are actually presenting in this symposium, which is good. So this is one of the opportunities for us as the HPC administrator to get together to share the problems and challenges. And once again, the Monash e-research center is very data focusing. As you can see, data is in the middle. And we know that from the beginning, since yesterday, this HPC and AI conference is very data focused as well. So we utilize the contributions and the partnerships that we have with other research entities in Australia to provide the governance and transparency to the researchers in Monash, as well as all the partners that we have. And at the same time, all the infrastructures and from the vendor in the industry to provide the capacity, the capability as well to the researchers. Some of the biggest projects that we have in Monash, including Massive, which is something that I'm going to talk about a little bit more in detail later. Ragmon, which is led by Sui here, is the research cloud in Monash. Big Notes is the Australian Research Data Storage Consortium, CVL Characterizations Virtual Laboratory, which is underpinning by Massive in this case. MyTardis, MIVP, those are the projects that we lead and for many, many years already. All these projects are providing the capability in terms of computing, the knowledge, the research outcomes to the discipline in Monash. You probably can't see the text because they're very small, but as you can see, the 14% of them are medicines and the biochemistry and molecular labs as well. So obviously we have other research projects in the e-research umbrella, but it's just not that main focus. So many of you are from Australia who already know what is the Australian Research Cloud, but for the international speakers or attendees, the Australian Research Cloud started in 2012, and so it provides the flexibility in terms of scalable computing environment to the Australian researchers. It allows the research community to store and access the data remotely and rapidly. And right now, there are around 40 vCPUs are in use. They're using a single API to integrate all 7 national partners. As you can see here, QCIF, Intersect, NCI, Monash, University of Tasmania, Melbourne, and URSA are all the partners for these main contributors to this Australian Research Cloud. Monash has been invested heavily into the computing and also part of the core services and provide those, the directions and the features to support the national research cloud community. I think Sui did want me to point out that Monash University has the highest vCPU usage. As of, this is last week, I think. Yeah. A little bit about Massive. So Massive is a GPU-centric data processing center. So we run computers called M3. This is the third generations of the supercomputers. And something is different about M3 is because it's sitting in the research cloud. Massive itself is the HPC facility center, and it is ISO quality accredited. So last year in around November, I think, we are ISO certified. And you can get the access to Massive through different locations. So some of them are NCMAS, which is led by NCI. And you can also get have the partnership with Massive by the integrations of the national instruments from different institutions through the CVR projects or being the Monash researchers. Some of the partners that we have, obviously Monash University is the biggest partners, and we have partnership with Ansible. Syro University of Wollongong has been coming on board since last year. Some of the affiliates partners, such as the Center of Excellence in Integrative Brain Functions, and the Advanced Molecular Imaging, which focusing on lots of cryo-EM. The instrument integrations that we supported or supporting right now is MBL, XFN, cryo-EM, MX, you name it. So all the instruments that you can find around the Australia has some sort of projects partnership with us. We used to have 3 computers, M1, M2. So early this year, we decommissioned M1 and M2. And so right now, we only have the M3, which is the one that's sitting in the cloud. We have about 6,000 cores. It's not big, but we do have high utilizations most of the time. As a GPU-centric computing center, we tend to have GPU in each of the boxes as well. So right now, we have close to 300 GPUs and 3 petabytes of parallel file system. We're using Lastar. Maybe by the end of this year, we'll probably have about 6 petabytes in productions. We're running out of space. Even though we are not as big, we do have about 400 plus active projects and 2,000 plus user account and collaborations across 100 plus institutions in Australia. Just a bit of highlights of the user communities that we have in M3. So this is the manual classifications of the M3 projects in 2018. As you can see, being life science focused, we have a lot of neuroscientists using M3. We have data processing projects from Ansible, cryo-EM, genomics. Genomics has come on board to M3 since early last year. And being genomics users, it has a lot of challenges for system admin to actually accommodate that workloads on the system. So a lot of our time last year was actually helping the genomics group to use the HPC alongside with our simulation cryo-EM users. So we have the partnership with Monash Bioinformatics platform to support the researchers in bioinformatics area, which is a really good thing because what we did was that we trained the bioinformaticians so that the bioinformaticians actually train the users. So it was a good outcome. So I think I did have the slide here. By the end of 2018, we have from 10 projects, we actually increased to about 80 projects or genomic projects in M3. And of course, machine learning as well. A little bit more about massive M3. So M3 cluster is in production since 2016 at Monash University. The actual machine is not in Monash University right now. It's in the Telstra data center, about 2 kilometers away from Clayton campus. So that's why it's not in Monash. It's a heterogeneous system to support heterogeneous workload. As you can see, we have different communities, and it is operated in a research cloud. So this slide, the 5,356 Haswell and Skylake CPU cores, it doesn't include the DGX machines that will be in a queue shortly in a couple of weeks. We don't have FPGA, so we use NVIDIA GPU co-processors for data processing and visualizations. We have all the variants that you can name, from Kepler to Volta. One of the new additions to the queue was the 66 NVIDIA Pascal P4, which was really good for the entry level of machine learning users to do their inferencing. And at the same time, we are using this P4 machine as a desktop to provide the desktop environment to the users. So the users can use a Strudel, a software that built in-house to spin up a desktop environment, something like GNOME or KDE, but in this case we use MAT, to provide a single point of access to the researchers, from collecting the data to processing and then visualize it. So the P4 was a really, really good success, I have to say. And right now we don't have users screaming and say, we don't have a desktop environment available. Okay, so apart from that, all the M3 compute nodes are connected to the 100 gigs of Mellanox Ethernet switches with running Cumulus. So this allows us to further software define our networking in Monash 03. Okay, so this is the part where I'm presenting 3 slides. So this is a high-level overview of Monash Research Clouds. So we have 3 cells in Monash, Monash 01, 02, and 03. 01 is more for the community cloud users. So you get your CPU cores and they serve as a backend storage. But when you come to Monash 02, we have a more specialized hardware, and you get a bit of attention when it comes to Monash 02 as well, that we work closely with the researchers and we collaborate to make sure that their application runs on those hardware. Monash 03, which is the, sorry. So this is Monash. So this is Monash 01, 02, and 03. So in Monash 03, so this is a private cell. So this is where the 2 supercomputers running on, and also some partnership hosts, which require a bit more secure environment running on Monash 03. So one of the things is that if you are already a Nectar research users that has allocations in Nectar, you can spin up an instance in 01 and 02, but you can't actually spin up the instance in 03 because that's purely for Monash purposes. So this is the architectures for Monash 03. As you can see here, that this line, so this line here is the hypervisor network. So we use Ionic, which is a project from OpenStack, to provision the hypervisor for all the new mapping HPC instances. We do have 6 DGX boxes in the data center now. There will be more coming later this year. and we're using the Laser file system for the high-performance computing file system. We also provide the redundancy for all the neutron provider network. So you can see here, so what we did is that we used the Monash interface and creating the virtual functions for the inside the hypervisor provided using the neutrons software to provide the network to the internal network to the HPC compute nodes, public network, as well as the restricted network. Not too sure what's restricted network here. Yep. So now we talk about the whole network architectures, the bare metal machines, and what do we have for each of the compute nodes. So each of the compute nodes, most of the HPC VM is one-to-one mapping to the bare metal. So what we did is we used the NUMA pinning to further optimizing some of these HPC VM. Each of these VM has the V100 or any GPU connected to using the pass-through technology to pass through all the way to the VM. And so, some of the hardware as well has the NVMe storage. We're using the Linux bridge to bridge the drive to the box, so we can use the drive as we want it. So we don't need the cloud team to do anything for us. This part, we are using the SR-IOV for the Monash interface, and this is the provide the low latency network to the Laser file systems. Yep. So we can't do this without using Ansible. So the whole idea of having the HPC in the cloud is that we can bring this knowledge, spin out any cluster in any cloud that you can name, hopefully. That's at least our goal. So we use Ansible to do provisioning, to configure the instance. We started using Ansible to configure the bare metal machine as well. So the reason why we choose Ansible is because it's portable and you can use tags. It does help a lot when you run the playbook. And using a lot of modules that is already available through Ansible Galaxy. And then, last but not least, we kind of having the CMDB in the repositories as well, which is really helpful. So right now, this is started in 2016, as I mentioned. So 3 years later, from having just one Ansible playbook to provision the VM, we have expanded that using the Ansible playbook to provision the bare metal, which is running Ubuntu, and then also configurations some of the OpenStack modules, and also provide the repositories to spin up the switches to which runs the Cumulus. So now that we have both the codes to provision the cluster in the cloud, why do we still need to worry about the hypervisor configurations? But in this case, we do, because we're using SRLV to present the card to the instances. So the dependency on the driver on the firmware is essentially a very time-consuming task for the sysadmin. So early this year, we decided to go with Ansible AWX, which provide a central on-premise task management platform. And it provides the internal team with a secure and centralized management interface to patch and to provision the servers. We use that as to schedule the workflow, to run Ansible playbook, to drain the nodes, to upgrade the hypervisor, and then upgrade the instances and return the computer in a queue. So many of you, as a HPC sysadmin, you're probably already doing the same thing, but we extend that capability into the bare metal machine as well. So a little bit about machine learning in Monash. We have a strong partnership with NVIDIA. We have NVIDIA fellow actually sitting in an office, in the same office as us. And apart from life science research, one of the biggest community that we have right now is machine learning. We help them to maximize the usage on GPU by introducing a bit more checkpointing in their ML jobs. And as of today, we have 6 DGX machines, and also we have the AI platform to support the community as well. This semester, we actually have allowing 150 undergrad students to use the NVIDIA P100 in another campus cluster, and which is supported by Monash HPC. Just a quick graph to show you the growth of the machine learning community in Monash. This is 2018 data, so it's actually more today. As you can see, Q1 last year, it was merely less than 100,000 of CPU usage, and the same as the GPU usage, but it goes so quickly in Q4 that we pretty much running out of CPUs and GPU resources for the machine learning users, hence the expansions of the DGX boxes. So some of these projects are the one that we supported or supporting right now in Monash E-Research Center. So such as the AI in dermatology, radiology, and you know what, I'm not trying to pronounce that word because I can't. So the one of the very interesting projects here is that it actually provides the clinical results using the AI technique. And so you probably can see the text, so I will send you the slide later. It actually tells the patient how many of them needs to be tested so that you prevent any further damage to the skin. My last slide. Since 2016, so there are lots of challenges. The things that I presented obviously is a good part, but we do have a lot of challenges and improvement that we need to do. So there are cases where bare metal are still preferable. So for example, the laser fast system and DGX boxes. But we do want to look into some of the capability from KVM or to virtualize the DGX machines. Work in progress. When it comes to virtualizations and OpenStack software as well, there are bugs that are not reported yet because we keep expanding our compute and capability. We often the first one that hit the bug, and we did not actually get enough attention from the community to fix it. So as of today, we're still having the KVM support for the problem for the any machine that have more than 1 terabyte memory. Very last one. the Ansible journey. So as I mentioned before, we started to use Ansible in all our infrastructure that we're maintaining. Lots of training and learning exercises for the team, and even outside of Monash E-Research Center, like the networks team that's sitting in a corporate environment. And how do we organize all this knowledge and repositories as well is a continued improvement for me or for everyone in e-research. Many thanks to all my colleagues for Nectar Cloud, Massive CVL, and obviously Monash E-Research. Thank you.